Everyday Reactions by Lisa Oram. What you already know. Matter can change in many ways. A physical change causes matter to change the way it looks, but it does not change the kind of matter. A banana undergoes a physical change when it is sliced. A whole banana and a sliced banana are both bananas. Slicing the fruit caused a physical change. One special physical change is a change in the state of the matter. There are three states of matter: liquid, solid, and gas. Liquid water freezes into ice. It changes from a liquid to a solid. Liquid water and ice are just different forms of the same kind of matter. A chemical change causes one kind of matter to change into another kind of matter. When wood is burned, it becomes ash and smoke. Ash is not wood. Ash cannot become wood again. Burning caused a chemical change. When two or more kinds of matter are combined, they can form a mixture. Mixtures are not a new kind of matter. Their ingredients can be separated. Salad is a mixture of several kinds of vegetables. A solution is a kind of mixture in which one or more substances dissolve in another. Lemonade powder mixed with water forms a solution. The powder dissolves in water. Many other changes in everyday life are pretty amazing. How does soap get you clean? How does food make you strong? This book explores how these everyday reactions work. Reactions all around. Have you ever used a cold pack on a sprained ankle? One kind of cold pack must be kept in the freezer to stay cold. Another kind of cold pack just needs a squeeze to become cold. When you squeeze this kind of pack, the substances inside mix together. One of them is water. The other is a chemical called ammonium nitrate. A reaction takes place when they are mixed together. This reaction takes in heat. Then the pack feels cold. Hot packs also take advantage of a reaction involving heat. Instead of ammonium nitrate, they are filled with either calcium chloride or magnesium sulfate. Both substances release heat when mixed with water. What about preparing cement to build a brick wall? Cement begins as a dry powder. Mixing it with water forms a paste, which is spread between the bricks. A reaction takes place. The paste dries to form a strong solid material. These reactions show the difference between a physical change and a chemical change. Adding water to cold and hot packs changes the temperature, but not the materials involved. It causes a physical change. Adding water to cement changes the materials involved. It causes a new kind of matter to form, which is a chemical change. Chemical changes require chemical reactions. Chemical reactions take place around us every day. Filling up. Chemical reactions even take place in the kitchen. For example, the heat of an oven can turn a mixture of ingredients into bread. Bread starts out as a dough mixture that includes yeast and sugar. When yeast and sugar react, it produces carbon dioxide gas. Kneading or pressing the dough makes it stringy and stretchy. Then the dough can trap the gas bubbles that are made by the yeast and sugar reaction. The dough rests after kneading. During that time, carbon dioxide bubbles fill the dough. Then it becomes light and spongy. Baking is the final step before you can eat the bread. When a car's airbag opens, it fills with gas, just like bread. Two chemicals are inside the airbag system. They are called sodium azide and potassium nitrate. When a car stops suddenly, a sensor inside the steering wheel generates an electrical current. This causes a spark, which ignites the sodium azide. The sodium azide reacts with the potassium nitrate to form a gas called nitrogen. This is a very powerful reaction. The nitrogen blasts into the airbag at a speed approaching 250 miles per hour, inflating the bag in an instant. Fortunately, the nitrogen moves out of the airbag quickly, and the car's passengers are able to move. Burning bright. Most people enjoy burning candles or sitting near a roaring campfire. But fire must be controlled. It can be very dangerous. What causes fire? Fuel, oxygen, and heat combine in a chemical reaction called combustion. Many different substances can be fuel for a fire. Wax, wood, and paper are all examples. Oxygen is a gas found in the air. When oxygen and fuel are mixed and heated to a high temperature, they will combust. Combustion is burning. When something burns, it is very hot. A candle burns brightly when an upside-down jar is first placed on top of it. The flame goes out when the oxygen in the jar is used up. Once a fire has started, it can grow quickly. As long as there is fuel and oxygen around, the fire will continue burning. To stop a fire, the fuel, heat, or oxygen must be taken away. If trees are cleared from around a forest fire, the fire will not have enough fuel. Spraying cool water onto the fuel source will lower the heat of a fire. And smothering a fire with water or foam will block oxygen. Firefighters use foam to cover materials that are no longer burning so they do not catch fire again. Coming clean. We would all be dirty without the chemistry of soap. Soap and water react in a way that makes it possible for us to wash dirt off ourselves or other surfaces. The particles of soap are long. One end of a soap particle is attracted to dirt and grease. This end surrounds any dirt on a surface, such as your hands. The other end of the soap particle is attracted to the particles of running water. The end of the soap particle that attracts dirt is also pulled toward the water particles. The attraction between the soap and water particles lifts dirt right off the surface. The running water then carries soap and dirt away. Soap is also used to get stains out of clothing. This kind of soap is called detergent. Some stains can be harder to remove. This happens when the particles of the stain and the fabric are similar. It can also be harder to remove a stain that has been rubbed in below the surface. Grass stains are often rubbed into pants. You can see the stain on the surface. but it is underneath too. The soap must get beneath the surface to get rid of the stain. Some fabrics, such as polyester and nylon, do not stain as easily. Their particles are different. The stain has a harder time attaching to the fabric. Digesting food. Have you ever thought about what happens to food after you eat it? Many chemical reactions take place in your body to digest food. Digestion is the process of breaking down food into tiny particles. Then, the particles can travel throughout your body. This is how you get the vitamins and minerals you need. Digestion begins in your mouth. Chemicals called enzymes start to break down food. Enzymes in your intestine break down food even more. Your stomach also produces hydrochloric acid, which turns food into a liquid paste. It also helps kill bacteria that may enter your stomach with food. The acid in your stomach is needed for digestion, but too much acid can make your stomach hurt. People take medicines called antacids when they have too much stomach acid. Sodium bicarbonate, or baking soda, is a common ingredient in antacids. It is the opposite of an acid. It is called a base. Bases react with acids to cancel out the effect of the acid. This process is called neutralization. When an acid and a base interact, they are neutralized. Pickling in vinegar kills bacteria, which is also what the acid in your stomach does. Indigestion remedies. If you want to see how an acid and a base work together, sprinkle some baking soda on a lemon. The fizzing you see is the acid and the base producing carbon dioxide gas. The gas is not an acid or a base. It is neutral. Battery action. Batteries are everywhere. There are different kinds of batteries for different uses. Can you think of some things that use battery power? You might have thought about a camera, a flashlight, or a cell phone. A battery is a container full of chemicals. All batteries have a positive and negative end, or terminal. A wire can connect these two terminals. When the terminals are connected, chemicals inside the battery react. The chemicals react to form electricity. This is called an electrochemical reaction. The electricity will travel from one terminal to another. Then, the camera, flashlight, or cell phone will work. When you want to listen to music, you simply turn on the radio. When you eat breakfast, your body gets energized for the day. The chemistry in your life is mostly invisible, but chemical reactions cause changes. These changes allow us to drive cars and use electrical appliances. They cause metal to rust, leaves to change their colors, fireflies to light up at night, and much more. Chemical reactions are an amazing part of life.